Hi, third graders. This is Mrs. Oyster, and today we are doing lesson 3 of our area unit, and we're going to kind of continue with what we did last time. We're going to find the area of rectilinear figures, but this time it's not going to be quite as easy. It's not going to be ones that have these grid squares inside that we can count. They will not have those squares. So we're going to have to use what we know about finding area of rectangles to find the areas of these rectilinear figures. Now, quick review, rectilinear figure is a polygon where all the edges meet at right angles. And I like to think of it as a polygon that can be partitioned or divided into rectangles. All right, so let's get started. Let's review what we did yesterday. I went ahead and highlighted these just to save us some time. We learned that if you have a figure like this, a rectilinear figure, you can partition it into rectangles, find the area of each individual rectangle, and add them together. So here, I have this, I don't even know what it looks like, but we've got this figure here, and I drew a line right here, and I partitioned it into this green rectangle and this blue rectangle. So this one is 1, 2, 3, 4, 5, 6, 7, 8 across. Is that right? Yes, it's right. Then 3 down, so 8 times 3 is 24. So this particular part of it has an area of 24. This rectangle is 4 across and 2 up, so this one has an area of 8. Remember, length times width is how we find the area of a rectangle. So to find the area of this whole figure, we're going to add 24 plus 8. And 24 plus 8 is 32. So the area of this whole figure would be 32. All right, down here I have a bigger shape, a bigger rectilinear figure, and I drew a line right here to partition it into this blue rectangle and this green rectangle. So this one up here is 5 by 5, and 5 times 5 is 25. So this rectangle has an area of 25. And this down here is 1, 2, 3, 4, 6, 7, 8, 9. 9 by 3, so 9 times 3 is 27. It has an area of 27. Then we add those two together. We have 25 plus 27, and that's going to equal 52. Okay, and we did this yesterday, so that might look familiar to you. So what I want you to do is in your packet, you're going to open to page 15. Now, if you have already picked up the new math packet, this is not there. This is in the one from last week, the one that on the cover says April 27th to May 8th. So this is not your brand new packet. It's the one we were working on last week, okay? And it's page 15, and it looks like this. All right, what we're going to do is find the area of these together. So if you don't have your packet and you don't have something to write with, pause this video, go grab those things, and then come back so that we can go over this together. Okay, so let's start with this one now. I'm going to go back and show you. See these two on the top, how they're the same? What I did is I just kind of chopped it apart and I put them side by side up vertically. Okay, so these are the one on your paper, they're side by side. Mine are on top of each other. Okay, so let's take a look at these. Now they're on a grid, but inside the figure itself, there are no squares, so we can't count the squares. So what we're going to do is we're going to partition it into different rectangles and find the area of those rectangles, add them together just like we have been, but we're going to have to be a little more mathematical about it. So this one I'm going to partition right here. Okay, so I made a rectangle here and a rectangle here. Now to figure out the area of this, I have to know the sides. So I'm going to use the grid on the outside to tell me the sides of this rectangle right here, okay? So this one is 3 across, and I'm going to write 3 inside so I don't get confused. And it is 4 squares long. So to find the area of this part of the figure, I'm going to multiply 3 times 4, and that's going to be 12, okay? Now this one over here is 4 across here, and 1, 2, 3, 4, 5, 6 across here. So the length times the width, 6 times 4 is 24. And so this portion of it has an area of 24. Then the next thing I'm going to do is add 24 plus 12, and that would be 36. So this figure has an area of 36. But what if I partitioned it a different way? Instead of cutting it here, I could cut it across here. So I could draw a line like this and make a rectangle up at the top and one at the bottom. So let's start at the top. This one is 1, 2, 3, 4, 5, 6, 7 squares long, and it's 4 squares wide. How do I find the area? Length times width, and 7 times 4 is 28. Okay, now this one down here, this one is 1, 2, 3, 4 squares across, and it's 2 squares up. Length times width. What is 4 times 2? It's 8. So then what do I do with these two areas, class? I add them together. So I'm going to do 28 plus 8, and guess what? It's 36. Well, my handwriting's getting messier by the minute. My hand's getting kind of tired of this. All right, nice work. So now you look at the two on the bottom of your page. Again, I put them on top of each other right here. And what I want you to do is pause the video, and then with your pencil, I want you to partition each of these into different ways. So choose one way to partition it here and one way here. Find the area of the two partitioned rectangles and add them together. All right, go ahead and pause and begin. Okay, so let's see how you did. I'm going to start here by just making the obvious cut and do that one right there. This has an area of 2 by 1. That's 2. This one's a little bit trickier, isn't it? This one is 1, 2, 3, 4, 5, 6, 7, and 6 across. So this is going to be 7 times 6, which is 42. What's 42 plus 2? I don't even really have to write that. It's going to be 44. Okay, nice work. Now the other way you could partition it is like this. Okay, so then we would have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. 6 by 6 has an area of 36. And this one, look, it's 1, so that's going to be easy. And it's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 times 1, which is 8. And 36 plus 8 is also 44. Okay, now class, I want to show you something that I sometimes see kids do. So I'm going to delete what I wrote here. I'm going to pretend that I decided to partition it like this. Okay, will that work? Will I be able to find the area if I find the area here and here? Well, the answer is kind of. If I leave it like this, I can't. Because is this a rectangle? This is not a rectangle anymore, is it? Look at this has 1, 2, 3, 4, 5, 6 sides. So we can, did I count that right? I think I did. 1, 2, 3, 4, 5. Yep, 6 sides. And we cannot find the area of a hexagon by doing length times width. Only rectangles. If I went like this and I partitioned it into 3 rectangles, then could I do that? Yes. But then I would have to find the area of this one, the area of this one, the area of this one, and add it all together. Okay, so you can partition into more than one rectangle. You can make as many rectangles as you want, but the more rectangles you make, the more numbers, the more areas you're going to need to add together. Okay, so when you partition these figures, make sure all the different parts are rectangles. All right, let's see what we've got here. So this is page 16 in that same math packet, the one from last week. And this one I'm going to consider a challenge, all right? So we will go through it together in this video. You are not going to be doing any independent practice with this because it's kind of challenging. If we were in a classroom and I could walk around and help you, that would be a different story. But we're going to consider it a challenge, and I'm just going to model it for you right now, okay? So this is page 16. And I'm going to start with this one right here. And I made a little mini picture of the page you have. This is this one. I made it big here. So I'm going to partition first, and then we're going to figure out the areas. And I'm just going to go like this. Okay? Now, this one down here is 7 across and 4 up. So I can figure out the area of this one by doing 7 times 4. 7 times 4 is 28. Now you might be saying, wait, Mrs. Oyster, it's 6 over here. Yes, the 6, though, is for this whole side. And when I partitioned it going just to here. And the length of this part of it is 4. Okay, so this rectangle is 7 by 4. Now, this is where it gets tricky, class. I don't know this length. I don't know this length. I don't know this length. We have to figure it out. So think about what we know about rectangles. We know that if this side is 4, the opposite side is 4, right? So this part right here is 4. Now we also know that this whole side is 6. So 4 plus whatever this is going to add up to 6. So what is this? It's 2, because 4 plus 2 is 6. All right, so now we figured out one part. Now we got to figure out this part here, okay? We know this is 5. And we know 5 plus this part is going to add up to 7. So what is this going to be? Also 2. So the area of this little part right here is 4. So I'm going to add 28 plus 4, and that would give me 32. The reason this is more challenging, class, is because it does not give you all the different side lengths. You have to use some algebraic thinking, some part-whole thinking to figure out the parts you don't know. Okay? All right, let's try the next one. So here, I am going to partition like this. I don't know why my lines always want to go down like that. Okay, let's start at the top. This is 5 and this is 3. Oh, so we have the side lengths we need for this part of the rectangle. 5 times 3, that's going to be 15. Okay, now here we have a side of 8, but I don't know this side, do I? I don't know this side. I do know that this plus this, or sorry, this and this are going to be the same length. So let's go up here. Let's see what I know. I know this rectangle. If this is 3, I also know this side must be 3. So 3 plus this part is going to add up to 6. So what is this part? 3 plus what makes 6? 3. So now I do know my lengths. I can do 8 times 3 is 24. I'm going to add them together, and the area would be 39. Now, at this point, if you feel like you are up for the challenge and you want to pause and try the next two on your own, go for it. Otherwise, I'll just quick go through them to model this for you. Okay, on this one, I'm going to go across like this. I know this bottom part right here is 7 times 4, okay? It's not 7 times 6 because 6 is this whole side, okay? And I am only figuring out this one right here. So 7 times 4 is 28. Now this rectangle, what I'm focusing on now, is 6 by something. I don't know what this is, though. I know this and this are going to be the same. I know this is 4, so this must be 4. So 4 plus this part right here has to add up to 6. 4 plus what makes 6? 2. So 6 times 2 is 12, so the area of this one is 12. Now if I add those together, 8 plus 2 is 10. I'm going to regroup the 1. And then 1 plus 1 is 2. 2 plus 2 is 4. So it has a total area of 40 square units. All right, good job if you happened to get that one on your own. One more. This is the last one on your paper. We're going to do it together. I'm going to partition. I think I'm going to do it like this time. I keep cutting them across. So let's do something a little different. Okay, so let's start here with this rectangle here. I know this is a side of 6. I know this is a side of 3. I have all the information I need. So length times width is 18. 6 times 3 is 18. Now for this one, I know this has a side of 4, but I don't know what these sides are, right? They're not labeled. I know this whole side here is 5, but I don't know what this piece is going to be. So let's use what we do know to figure it out. I know about rectangles that opposite sides are the same. So if this is 3, I know that this part is 3 right here. 3 plus this piece are going to make a total length of 5. So 3 plus what makes 5? That would be 2. Now I know my side lengths, and I can multiply length times width. 4 times 2 is 8. And if I add 18 plus 8, I would get 26 square units. All right, class, this is a complicated skill here, and it's hard to teach without being in person. But thank you for following along and doing the work in your packet. I am not going to be assigning you an independent practice for this because I do believe this is something that we really need to do in person. But I wanted to make sure you at least were aware of the strategies and how to do it. So nice work, class. We will be moving on to our next lesson about perimeter tomorrow. All right, nice job. Thanks for listening.